Hello everybody and welcome to our video lesson on a very interesting topic, I must say. And these are actually quadratic equations that are not quadratic like what we've been looking at, but they are what we call quadratic in form or quadratic in nature. That is, the equations come to us in form A, if you will, and then our goal is to recognize that we can make a little substitution, put them in a quadratic form, then use either factoring, completing the square, or um, the quadratic formula to solve this thing, then resubstitute for the original variable, and then go ahead and solve in terms of the original variable. That is one method we'll use. It's basically what we call a substitution method. And then we'll have one little rational thing that I'll throw in for posterity's sake. So let's take a look real quick at what we're going to be taking a look at here in a few minutes. So we have x to the 2/3. Okay, so x to the 2/3 minus 3x to the 1/3 minus 10 equals 0. Now notice that we have this trinomial, but the variables now are raised to rational exponents. And let's take a look at 20 x to the 2/3 minus 6x to the 1/3 minus 2 equals 0. So we're going to take a look at these two, kind of similar in nature. All right, and then we're going to take a look at another one that's in the form, say, 5n plus 1 squared plus 2 5n plus 1 minus 3 equals 0. And then let's see, p plus 2 squared equals 9p plus 2 minus 20. Okay, so notice that this one has something involving a square, and this one has something involving a square and stuff on the other side. We already know how to deal with quadratics that have stuff on the other side. Again, a little hint reminder is bring everything to one side. All right, and then I would be remiss if we didn't take a look at least one of these. 3x, 3 over x, I should say, plus 4 over x plus 2 equals 2. All right, so every one of these equations here we say are quadratic in form or quadratic in nature. So let's take a look at the down and dirties of number 1 here. So x to the 2/3 minus 3x to the 1/3 minus 10 equals 0. So let's just recall that when we have rational exponents, so a to the 1 over m, let's recall that the numerator is the power. It's the power that we're going to raise that base, and n is the index. It's the index to the radical. So here we can see that this x to the 2/3 is really x squared, and then we take the cube root. And notice here that this is just an x. So let's just observe that based upon what we just said here, I can rewrite this as x to the 1/3 squared using my rules of exponents minus 3x to the 1/3 minus 10 equals 0. So notice it appears now that I have something to a squared, and then we have our linear, and then we have our constant. So let's just observe that we can go make a substitution, and we'll say let u equal x to the 1/3. This is a common thing to do, since we have this thing now that is a quadratic in form. So I have something squared minus 3 times that something minus 10, our constant, equals 0. So if I make this substitution, notice what happens after the substitution. Everywhere I see an x to the 1/3, we'll put in a u. So notice I put a u here. I get u squared minus 3. Notice here, I have my 1/3. I replace that with a u. Minus 10 equals 0. And notice this whole thing now collapses to our quadratic equation. And now we've got three ways that we've discussed. We've got factoring. We've got the quadratic formula. And then we have our least desirable method, and that is completing, or at least my least favorable, completing the square. Now let's just note that completing the square, my comment that I made, least favorable, it is a tool to use. It's just that this one and this one are pretty much the down and dirties, and makes things happen really nicely. Completing the square is something that you're going to see later on in college algebra. That's a tool and a technique you're going to use, especially when you have quadratic stuff in two variables, like x squared plus y, or x squared plus something involving x, and then a y squared plus something involving a y. So then you get into these conic sections, and that's a whole different discussion, but you use a completing the square technique. So let's just note that in this case, I'm going to try taking a look. Let's see if we can't factor this. So the question is can I come up with factors of negative 10, again, that add up and give me this 3? So let's see. So negative 10, so we get 5 and negative 2 and negative 2 and 5. So let's just note that 5 times negative 2 is our negative 10. 5 minus 2 is 3, so that doesn't work. So we can get rid of that. So now we have negative 2 times 5 gives me my negative 10. If I add these two, oh, this is the same thing, sorry. I meant to write negative 5 and 2. So notice if we product these, we get the negative 10, and notice if I add these, I get my negative 3. So that means now I can factor this to u minus 5, and then u plus 2. So then we can split these apart. So let's just notice that we get u minus 5 equals 0. So u equals 5. All right. And then over here we get u plus 2 equals 0. So u equals negative 2. All right. So we have solved this for u, but notice that our original variable is x. So this is where we have to now resubstitute. So we have to resubstitute. All right. So note that we said u was equal to x to the 1/3. So let's just note that this is x to the 1/3 equals 5. So this means that the cubed root of x equals 5, which means that x equals 5 cubed, which is 125. So now we have gone back to resubstitute to find our solution back into the original variable x. So we have to, again, solve these in terms of our original variable. So again, over here on this side, we get x to the 1/3 equals negative 2. So this is the cubed root of x equals negative 2. So cubing both sides, I get x equals negative 2 cubed equals 8. All right, so now we can validate our solution. So let me just bring the equation down here so we got something closer. So x to the 2/3 minus 3x to the 1/3 minus 10 equals 0. So we can go ahead and validate our solution. So let's just note that we get 125 to the 2/3 minus 3 times 125 to the 1/3 minus 10 equals 0. So let's just observe, recall earlier, to evaluate this, we rewrite this as the cubed root of 125, and then we'll go ahead and square that, minus 3 times the cubed root of 125 minus 10, and we want to see if this is equal to 0. So we know that the cubed root of 125 is 5 squared minus 3, and the cubed root of 125 is 5, minus 10, and we want to know, does that equal to 0? So 25 minus 15 minus 10 equals 0. And notice that 25 minus 15, so we get 10 minus 10, and that does indeed equal 0. So let's try this with the 8. So we get 8 to the 2/3 minus 3, 8 to the 1/3 minus 10 equals 0. So again, I just want to point out this fact right here as a method of retrieval, and to recall that we talked about how to do this back in sections 10.1. So this is a retrieval for you. We did talk about this. So let's note we get the cubed root of 8, and then we'll raise this squared, minus 3 cubed root of 8 minus 10 equals 0. So note that the cubed root of 8 is 4. 4 squared is 16 minus 3. Cubed root of 8 is 2. 3 times 2 is 6. Plus 10, or minus 10 equals 0. So 16 minus 6 is 10. 10 minus 10 is 0. So this checks. So that is a way to validate our solutions for this exercise. So let's just take a look now. We got 20 x to the 2/3 minus 6 x to the 1/3 minus 2 equals 0. So these are kind of popular to do. So again, we get let x or u equal x to the 1/3. Right? So hopefully this goes without saying. We just did this. So come back over here. So we get 20u squared minus 6u minus 2 equals 0. Okay? And so one thing that I'm observing is that for each one of these coefficients are even. So I'm just going to make these things smaller. So I just want to go ahead and divide both sides by 2. So I get 10u squared minus 3u minus 1 equals 0. Now I know you're probably asking, well, do I have to do that? And the answer is no. I like to just make my numbers smaller. They make life easier to deal with. So since we use factoring, let's go ahead and use the quadratic formula. P.S. Let's just note that 10 times negative 1 is negative 10. So we get 2, negative 5, negative 2, 5. We get negative 1 and 10 and negative 1. And I'm sure that this thing will go ahead and factor, but I don't really want to go through the factoring technique on this one. Okay, I want to go ahead and use the quadratic formula. So let's note that in this case, A equals 10, B equals minus 3, and C equals negative 1, just so we can get a little flavor in here. Okay. So that being the case, so we get the fact that u equals negative b plus or minus the square root of b squared minus 4 times a times c, okay, divided by 2a. Okay, so here we get 3 plus or minus the square root of 9, and negative 4 times 10 times negative 1. So I'll do this whole product. We can easily see we get plus 40. I don't know why I wrote 2a here. This should be a 10. Sorry. Divided by 20. So we get that this is 3 plus or minus the square root of 49 divided by 20, which is equal to 3 plus or minus 7 divided by 20. So let's just note here that this says that u is equal to 3 plus 7 divided by 20, and u is 3 minus 7 divided by 20, which says that u is equal to 10 over 20, which is equal to 1/2. And this says that we get negative 4 over 20, which is negative 1/5. So now we have to resubstitute at this point in time. So x to the 1/3 equals 1/2. So the cubed root of x equals 1/2. So x equals 1/2 cubed, which is 1/8. And over here we get x to the 1/3 equals negative 1/5. So the cubed root of x equals negative 1/5. So we have that x equals negative 1/5 cubed, which is equal to negative 1 over 125. Okay, and you can go ahead, if you wish, and verify those solutions, which I've already done, and they do work out. All right, so let's go to another flavor that is quadratic in form, and that is 5n plus 1 squared plus 2 5n plus 1 minus 3 equals 0. So again, we can observe that we have something squared, we have that linear form of something, and we have our constant. So this appears to be a trinomial that is quadratic in nature. So again, let u equal 5n plus 1. So I'll come over here and notice that when I make the substitution, we get u squared plus 2u minus 3 equals 0. Okay? So again, now let's see if we can employ our factoring technique. So let's see. Here we got negative 3. So we get negative 3 and 1, and 3 and negative 1 are the only factors. So which one of these will multiply to negative 3, and which one of these will add up to 2? So I'm seeing this guy here. So this factors to u plus 3 and u minus 1. See, the factoring is pretty nice. It's pretty down and dirty. All right, so it makes life a little nice. So here we get u plus 3 equals 0. So u equals negative 3. And over here we get u minus 1 is 0. So u equals 1. So resubstituting for u, I get 5n plus 1 equals negative 3. So 5n equals negative 4. So n equals to a negative 4/5. Okay, and then over here we get 5n plus 1 equals 1. So 5n equals 0. So n equals 0. So these are our two solutions. All right, so for our next one, let's take a look at something that is, again, kind of a repeat. So p plus 2 squared equals 9p plus 2 minus 20. What I'd like for you to do is to go ahead and do this one and bring your answer to class. This will give us something to discuss in class when we meet. All right. But I would be remiss if we did not talk about our good old rationals here. So 3 over x plus 4 over x plus 2 equals 2. So we've already talked about how to solve these. It's just the difference between what we talked about here and what we talked about previous is this one's going to end up being quadratic. So again, notice that when we have our fractions, let's just observe that right off the bat, we cannot have x equals to 0. And we cannot have x equals negative 2 because notice that for x equals 0, this becomes 0, and we know we can't have that. And notice that negative 2 will make that denominator equal to 0. So we know that these two cannot be answers. So as we go through our solution, if we end up with one of those as our solution, we just kind of ditch it. All right. But let's go ahead and take a look-see. So let's just recall that when we have these fractions, we multiply by x plus 2. So we get 3 over x plus 4 over x plus 2 equals 2x plus 2. I don't know why I put brackets around that. Let's just write this 2x. Okay, so then we'll go ahead and distribute this across the addition. So we end up with 3 over x plus 2 plus 4 over x plus 2 x plus 2 equals, go ahead and distribute this across. So we get 2x squared plus 4x. Notice here, there's where our x squared gets introduced. See if we get any more. So this x cancels with this x, so I get 3x plus 2 plus these two cancel out, so I end up with 4x equals 2x squared plus 4x. So distribute here, so 3x plus 6 plus 4x equals 2x squared plus 4x. So combining like terms on the left, so 7x plus 6 equals 2x squared plus 4x. And now I'm just going to bring all of this stuff to the other side because I'm seeing I got quadratic. And I like my leading coefficient to be positive. All right, makes nice things happen. So I'm going to get my 2x squared. So when I subtract both sides by 7x, I get minus 3x. And when I subtract the 6x, I get minus 6 equals 0. So I can't divide by anything here. All right, so I'd like to go ahead again one more time. And since we did a couple of factoring, I'd like to go ahead and use the quadratic formula. Again, it just doesn't really matter. If it factors, great. If it doesn't, great. I think I checked on this one, and to be honest, I don't think this one factors. So negative 12. So notice the factors of negative 12 is 2 and negative 6, negative 2 and 6, 3, negative 4, and negative 3 and 4. And I don't think any of these add up and gives us a negative 3 unless I'm missing something here. So factoring does not work. So we'll go ahead and use the quadratic formula. So let's just note that a equals 2, b equals negative 3, and c equals negative 6. So here we get x equals negative of a negative 3 plus or minus the square root of negative 3 squared minus 4ac. Go ahead and get rid of these guys out of the way. Okay. Divided by 2a. All right, so let's just note we get 3 plus or minus the square root of 9 plus 6 times 2 is 12 times 4 is 48 divided by 4. So this is 3 plus or minus the square root of 57 divided by 4. And I don't think there's anything that will come out of this square root. So notice this says that x1 is equal to 3 plus the square root of 57 over 4, and x2 equals 3 minus the square root of 57 divided by 4. So I don't think this is divisible by 4. Nope. I know it's not divisible by 9. Nope. 2. So 4, 9, 16. Nah, I don't think anything's going to work on this one. Let's see. 20s. 25 is not going to work. Yeah. So I stand by that these are the two appropriate solutions. All right, so this is just a snapshot of some of these quadratic informs. Again, this is something and a tool that you're going to use in your college algebra class, and yes, you will probably use it again in your calculus course. So anyways, if you have any questions, please be sure to share with me on the warm-ups. If not, bring any questions you may have in class. And if there are any errors, I'll give you some extra credit on that one as well if you can spot them and find them out. And you are correct. All right, outside of that, have a great night, and I will see you in class. Bye.